Okay, let's get started. Hello, everyone. So today's March 6th is a beautiful sunny Sunday, and I'm doing this Method 24 final exam review part 1. Today I combine part 1 and part 2 together. For 105 to all the way to 325-ish. So it's gonna be Method 24 final exam review. Because I think just instead of write like a tons of handwritten note, just let them to read it. I think it's like make a videos more engaging for like final exam. Because like I think learning is better than like active learning rather than passive, just like memorizing. Because people get more out of it with active learning. So today we're gonna do part 1, but like basic derivative and the limit. And this is the most foundation of the Method 24. And it's being a way to front of the ulti-final. If you want to get a 2.0, I really recommend you must get those points right, because those are easiest to problem on the final. Because if you can't get those problems right, I highly gonna, and I can say you're not gonna get any high marks if you get those questions wrong. Okay, let's back to the business here. So I randomly chose some question from the old finals, and the first question is from the winter 20s 16 question 1. So this is part A. It had like a limit here. So it's like a limit. X approaches 0 of x sine of pi x. And so if you do just this sine of pi, and you just know the trig values here, and just look, I think that any time you have like a limit, so what you should look at it is like indeterminate form, and sine of pi x sine of pi is 0, then is also a 0. So this limit, we have a top 0 and the bottom, and this has this indeterminate form. And now we need to conjugate or use L'Hospital's rule. So if in this cases, and you try to conjugate or factor, but this is no polynomials there. The only thing we can do is just a composite function here. So we're calling chain rule from section 3.4. So we can use like a L'Hospital's rule and call them LH, because you don't want the denominator is 0, right? Because that just to make the limit undefined. But it can be solved. So when is LH, do not use quotient rule because they're individual functions. And this time we have like a limit x approaches 0, the derivative of x is 1. Now it's the chain rule here, pi. So constant we have is pi cosine of pi x. Now we calculate it's like 1. And what is the bottom? Right? For cosine pi, it is 1. So now we can put the limit, it is 1 over pi over 1. So the limit is 1 over pi. So if you ever see like the numerator is 0, bottom is also a 0, don't panic. So we have multiple ways to solve the limit. If you see like a radical conjugate, if you see polynomial factor and then cancel, if you see this, use L'Hopital's rules. The next one, question 1b, it is like the limit. Let's put like 3 x minus 3 and then minus 1. We have is x squared minus 4x plus 2. Now we write like the indeterminate form. E to the power of O, it is 1. Then so it's e to the 0, it is 1. 1 minus 1 is a 0. And 3 times 3 is 9. 9 minus 12 is going to be negative. 9 minus 12, it's going to be like a negative 3. Then plus a negative 1 over a 0. It's a 0. Actually, this one, it is easier because there's no like cancel, no elementary rule allowed. So this one could be your easiest you can expect on the final exam. Because if the numerator is a 0, then the whole thing is a 0. Part C, not a limit. It's like a limit. X approaches infinity here. 4x minus 16x squared plus 2x plus 1. Okay, if you ever see like a radical, another term, so write it. So this time I treat the denominator as 1. So the denominator is 1. And then we rewrite the limit. And then conjugate, there's a radical. Now it's time to conjugate the limit because you want this just the numerator to look nicer. Then just to conjugate this numerator. Then this is the bottom, because multiply this term, I need to put them back there. Now just expand them out. Be careful about the negative sign, because some just messed up, then the whole thing gonna mess it up. So be careful about like a negative sign. Sixteen x to the squared minus 16x to the squared plus 2x plus 1. Have this on the bottom. Gonna be 4x plus 16x to the square plus 2x plus 1. And then you just make the top nicer. So it's going to be negative 2x and minus 1. Then now use 2.6. Use select 2.6 strategies. Then there's the 2.6, so like a limit law here. You just put them in there. It's gonna be negative 2x over x minus 1 over x over 4x over x, and this you just put them in there. So going to be 16x squared over x to the squared, and then plus 2x over x to the squared plus 1 over x to the squared. And then it's like, look at negative 2 and a 0. Bottom going to be 4 plus 4 is 8. So it's going to be negative 1 over 4. It is our answer. Okay, so it just needs some algebra and like the limit laws. That's just to solve all like a limit. And question 1D, it is derivative. It is, if we have this f of x, it is x to the pi plus pi to the x plus cosine to the pi, cosine of pi x minus e to the pi. Okay, then we need to use like multiple like laws here. So let's just row. So let's pull out like the so let's just like derivative laws here. Okay, So now in this case, we need like a logarithm differentiation, the chain rule, and the power rule. So differentiation rules needed. So you have a logarithm and chain rule and power rule. Now there are four different expressions. So you just need to treat them as four individual functions here. So f of x, it is pi is a constant. X is a variable, so we have pi x pi minus 1. And we plus is pi to the x and to the natural log of pi. Make sure this is chain rule. So it's going to be negative sine. So it's going to be negative pi sine of pi x. E pi is a constant. So is a 0. That is the derivative. Question E. Okay, this is like a function, another function. So it's like power function, another function. So it's logarithm differentiation. So every time if you see like power to another power, so it's like any time if y equals to f of x power to the g of x, use logarithm. The only exception it is e to the f of x. Use the chain rule can be done. So we first do logarithm differentiation. Our step it is right as the natural log of y it is gx, it is x squared, f of x, it's a tangent of x. So gx is going to be x squared, and the natural log of f of x. Use the chain rule and the product rule. And now we have so 1 over y dy dx equals 2 is we have gx is like a chain rule. Times the 1 over tangent of x, and then we have is secant squared of x. This is derivative. plus g prime of x is going to be 2x times like a natural log of a tangent of x. Okay, now it's a cotangent of x. Just rewrite the trig identity here, because that just to make them easier to solve. Gx is gonna be x squared is sine x is cosine x over sine actually. All right, this is a cotangent. I'm so sorry. This is a cotangent. So it's cosine of x on the top. Sine of x is on the bottom. We have the 1 over cosine of x, cosine squared of x. This remain unchanged. And then we will have a y to the whole side. Gonna be dy dx is equal to this mess, okay? Cosine is, so we still have a cosine of x here. This just the cancel. X squared over, so gonna be x squared over sine of x, cosine of x plus 2x natural log of tangent of x. And the big parentheses here. And the y is this, the function itself. So f prime of x, it is equal to the tangent of x power to the x squared. I multiply by this expression. Plus 2x over natural log of tangent of x. And that's just what you want for derivative of a logarithm differentiation. Okay, and just rewrite them as a trig identity, but you can put them there. They're the same thing. So they're the same, but I just wrote them a trig identity, so like know how they just they're interchangeable. Interchangeable. They're it's the same thing. Those are basically the same. So now you know how this has come, right? Another exam is fall 2015. We are going on like a basic derivative and the limit. Okay, so it's gonna be 1A. This is autumn 2015. It's on the final exam. Question 1 and start from 1A. Find the derivative. I think this problem just you guys maybe hate the most because this appear on like the web design. It's not fun, right? Over e to the t plus 1. Okay, if you ever see like a radical inside the function, use the chain rule and the quotient rule. Okay. Inside function, I think now we can use the power rule because square root is power of 1/2. So we rewrite them as this will be easier just to see that it is easier to comprehend in a power rule form. And we use the chain rule at here. U equals 2 this chunk du use the derivative rules is a quotient rule. Oh man, just hate this derivative so much. And if you just minus f of x, sorry if I make too many mistakes here. Plus 1 and the derivative of a e equals 1 is e t. I forgot to multiply this. Oh, jeez. I'm just trying to warn you. Sometimes like those tiny mistakes just mess up everything. So be careful, okay? Then the bottom is gonna be et plus 1 to the squared. And you don't need to expand this. You just need to use the chain rule and find the derivative. That's all we go. Just don't overcomplicate everything, okay? Then use the power rule and the chain rule. There's no product group here. We just multiply them this and I know this is a mess. Just multiply everything minus the 4 plus 1 to the e to the t over this like messy squares times 1/2 using a negative 1/2. Then the final expression, that is f prime of t, it is 4t to the cubic et plus 1 minus t4 plus 1 e to the t over et plus 1 to the square, and then going to be 1/2. It's going to be like t4 plus 1 et plus 1 to the negative 1/2. I think just leave them there because all are going to be really, really messy answer. So this is what you're going to expect for this. If this is a messy functions. Draw the box, but it is imperfect. So just trying to just trying to suggest don't ignore those like a tiny mistake, because those are the things just really doesn't mess up. You just be careful, okay? Next one. And next one is easier. It is f of x. It is 3 the arctangent of x. F of 3 is a constant. Inverse tangent is a function. Then what is the derivative of such function, right? So if you see some non-normal power functions, your first reaction should use logarithm differentiation. Just use them, and it's like f of x, g of x. So we use this. And for this one, it is just feel thing just like a chain rule. So we only remember this, and this is when what we needed to do with this kind of a limit, or like the derivative. It'll be like natural log of a, then f prime of x. To remember this, just make life easier. Otherwise, you're gonna find, okay, what the hell I'm gonna use, right? And now, okay, you find a formula, you find an equation here, then just okay, just plug the chart there. It's gonna be 3 inverse tangent of x by natural log of 3 inverse tangent. It is 1 over x to the squared plus 1. So we can write the whole expression as three inverse tangent of x to the natural log of 3 over x squared plus 1, and that is your answer. Let's move on. I think for this one is more like chain rule, but it's doable. You don't need to do any computation. Just I think this one tends to be more more conceptual rather than computational. So 1C, if f prime of f2 it is 4, f g2 it is 2. And g prime of 2 it is 6. And then f and g prime 2 it is 3. Find f prime of 2. Okay, so we see f2 is 4, the f prime of 2 is a 0. No. Don't ever say that. They have conditions, and this is so. This problem one is conceptually understanding the quotient rule. So don't say f prime of 2 is a 0. No, that doesn't mean just conceptual understanding of the quotient rule. So what is a quotient rule? So it is so it's gonna be f prime of x then g minus g prime times f, and then it's gonna be g to the squared, right? So this is the quotient rule. And we are thinking for like the 3, it is, I mean, just put them in there at 2, or x equal to 2, f prime of 2, and we put them there, and multiply by g2 is 2, minus g prime of 2 it is 6, we have f2 it is 4. We have g2 is 2 times 4. And then we have this 3, it is 2f prime of 2 minus 24 over 4. It is equal to 3. And then we cross multiply 12 equal to 2 f prime of 2 minus 24 to f prime of 2, it is 36. F prime of 2, it is 18. That is what we want from the quotient rule. And we do like a backward check. So if f prime of f prime of 2 times g2 minus g prime of 2 times f2 over g to the 2 to the squared. So it's going to be f prime of 2 is 18, g times 2 is 2, and minus g prime of 2 is 6, 5 of 2 is 4. And then we have this g prime of g2 is 2 times 2 is 4. So it is going to be 36 minus 24. 12 over 4 is 3 is correct. So f prime of 2 is 18. That is what you want. Let's move on to the limit. 1D, question 1D. A is a positive constant. To check my phone, make sure that there's nothing is I missed or whatever it is. Solve the limit. Okay, if you're plugging x into A, it's a 0-0 limit. And this is we need to conjugate, find a common denominator, then cancel. So it's elementary method. So it's going to be conjugate. Cancel. Now let's just do this limit. Multiply by x and a. And for get rid of a numerator, we must make them the same thing. So multiply the ax by everything. And then we just multiply them. visual algebra here. We have is a minus x. That's gonna be like ax times x minus a. Okay, this is like a negative reciprocal of this. And now we're just gonna do some algebra trick here. X minus a is canceled. So what you get is this. So it's gonna be -1 over ax. So it's gonna be -1 over a to the squared. I think this is like easier limit that we can expect on the final exam. Well, question E is gonna be the hardest of this of the fall 2015 exam. So it's like the limit x approaches infinity of x plus sine of x, then x to the natural log of x multiplied by natural log of x, and then 2x plus 1 I'm going to borderline here. Apologize for it. Sometimes I just can't remember the thing, right? And I hope this is not like normality, because I just trying to get everything out of it. We rewrite the limit, then just L'Hopital rules. I change different color because there's ice or a lot of orange and everything. So get the L'Hopital rules. Make sure you use the product rule here. Apply the product rule. Gonna be like a limit of x approaches infinity here. So we have this gonna be x plus sine of x times 2x plus 1. We have like derivative of 4x plus 1. Wow, this is a long expression. 4x plus 1 plus 2x cosine of x plus cosine of x plus 2 sine of x to the natural log of x. This is another derivative. It's a 1 plus natural log of x. Now let's do like a limit law here. So if you remember 2.6, I select a limit. It's gonna it's gonna be infinite cases here. Now I have this indeterminate form. It's gonna be infinity form. Then just try to do like another Logarithm rules. Later find it's not gonna happen because if you do like undefined, it's gonna be like a 0, 0, 0, 0 undefined. In this case, if you just set like okay, then like a limit is it, and then it's gonna be like the infinity, because if you take the derivative of 1 plus natural log of x, you will see is the denominator gonna be a 0. Because the denominator eventually becomes a 0. Now let's move on to the next question. Oh, this is my exam. This question is on my exam. G01. G01 is part of 1A, is the derivative. If we found like it is f of x, it is the square root of sine of x squared minus sine squared of 2x inside a radical. So the first immediate response, okay, use the chain rule and the chain rule. So you like the chain rule multiple times. With multiple chain rules. I know this is painful, but you might expect on a final exam there will be multiple chain rule problems. So it's gonna be sine of x to the squared minus sine to the squared of 2x. And then gonna be the du gonna be u to the 1/2. And then just solve this limit there. No, solve this chain rule. So chain rule. So the dx of sine to the x to the squared is gonna be, if inside function it is a 2x, no, it's x to the squared. Outside function it is sine of x. It's gonna be this. Cosine is derivative. Another chain is like x to the squared. That is there's gonna be multiple chain rule for this function. And the inside function it is x to the squared. Like a chain with the cover rules. So this is gonna be really tough, but it's doable. So we turn the 2x, we need to chain rule by twice, then we get is gonna be 4 sine of 2x cosine 2x. Wow, this is complicated, right? And then back to the main function here again. So f prime of x, it is gonna be this minus this, so it's gonna be 2x cosine x to the squared minus 4 sine of 2x cosine of 2x times 1/2 u to the negative 1/2. Well, in this case, is u, it is sine of x to the squared minus the square root of 2x. And then 1b, it should be easier because it's a quotient rule and like a very easy chain rule. So let's get started. Do is gonna have g of x gonna be 8 power to the x plus e sum x minus 2 over x squared plus 2. Okay, just quotient rule, chain rule, and logarithm differentiation. And quotient. And then we just try to break down into two different expressions, we have is gonna be g prime s is gonna be 8x in natural log of 8 plus gonna be x squared plus 2 to the square. Don't expand it because it's gonna be like whole different messes here. Because I don't want you just to make lots of messes sound like an unnecessary thing because it's time constraint. So let's do the quadrant rule. So the bottom function, we have at prime x, it's gonna be 7e 7x minus 2 multiply by gx on the x squared plus 2. We have is gonna be minus the bottom are gonna be 2x times e to the 7x minus 2. That's your final answer. It's like it seems hard, but it's not. Question 2 on my exam is going to be like the limit. So let's roll this first question. So it's like a limit. X approaches number 3 is going to be 8x plus 1 minus 5 over x to the cubic minus 9x. Oh wow, we have this radical, we have polynomials, and this indeterminate form is a 0 and a 0. So conjugate a factor. So we have like a limit. You can see it up on camera. For conjugate, it's just gonna be 8x minus 24. I just omitted the conjugate form because it's like we have very limited space here. And it's gonna be factor x out of here. X squared minus 9. We have is x plus 1 plus 5. You should know what is being conjugated, right? Factor x minus 3 because now you need to do like a factor here. They still have this exist. You have it's gonna be like a limit of the 3 gonna be 8 over x plus 3, and then it's gonna be 8x plus 1 and plus 5. It is gonna be 3 times 6, 18, 180 over 8. 25 is 5, 10 times 6 180 over and divided by 4 could be 2 over 45. That's his final answer. Wow, solve this limit. And then the next one is going to be like a L'Hopital's rule. No many of it going to be hated. L'Hopital's rule. There's no ink at this pen, so I need to change a new one. I'm sorry if this happens today because I wasn't expected. Wow. Well, just wait. Okay, now back to it. Question 2B of my exam. So going to like a limit. X approaches 0. 1 minus cosine of x over sine squared of 2x. So I think it is another thing to rewrite is sine squared of 2x here. So it's like you just need a here's some trig identities here that just maybe just to trick you to do like anything that you want. So it's like so trig identities here. Sine squared of 2x. It is gonna be 1/2 times the 1 minus cosine of 4x. Trig identity if is for this one. Now we just okay, this might be easier, right? The 4x indeterminate form is a 0, 0 limit. These L'Hopital's rules. So a limit is gonna be like x approaches like 0 is gonna be sine of x. We distributed this, so gonna be negative. So it's gonna be 2 sine of 2x. So gonna be 2 sine of 4x. Like 0, 0 again, And then like L'Hopital's rule again. L'Hopital again. Until the denominator is not a 0. Cosine of x gonna be 8 cosine of 4x. Now it's not a 0 and a 0. Cosine of 0 is a 1. The cosine of 0 is a 1, so it's a 1 over 8. That's just the answer. Sometimes you need to use L'Hopital rules more than once, and this is the case. And then it's going to winter 2013 right now. Winter 2013 is like another exam. But now just the first they're gonna be. So by watching this video, you already know how to do my first 2 problems of my fake exam. Now it's gonna be winter 2013 in question 1. Question 1, we have a 1a. Derivative we have is f of x. It is 5x squared plus 2x minus 1 of ex. Okay, this maybe tell me they didn't want to use like just to use the power rule just to rewrite them easy, but it's not because of the ex. Oh darn it! Quotient rule. So maybe just needed to do something about it. I'll do the quotient rule and then just gonna do everything here. Quotient rule. Ex to the x is gonna be e2x. So it's gonna quotient rule. Let's apply the quotient rule here. F prime of x, it is gonna be 10x plus 2 to the ex minus like derivative of gx is gonna be ex 5x squared plus 2x plus and then minus 1 e2x. Simplify for a bit. The ex of they're going to be negative 5x to the squared plus 2. It's going to be plus 3 to the 2x. That is what we expect from this derivative here. You just expand x on 8x max 5x. Yep. And next one is the chain rule, and the chain rule. And I bet you just hate it, right? I hate either, but solve them, and then you're not gonna face this thing for like a while. So like a better version of this. Okay, and then punch 1B. Hmm, 1B. We have gonna be f of x equals to cosine of e to the x to the cubic plus pi minus inverse tangent of x to the squared. Only way is the chain rule. That's it. Just like make sure you just apply all like derivative rules here. So gonna be negative 3x squared dx sine of e to the x to the cubic plus pi, because the pi is a constant. We just like take the derivative of it. Minus gonna be 2x and multiply by this du over inverse tangent of x. And then just compile the whole masses here. Minus 3x to the squared u to the x sine of e to the x to the cubic plus pi. And minus it's gonna be like x to the squared equals x4 plus 1. X squared plus 1. Oh, wow. This is like another mistake, but I caught them. This is a good thing. Gonna be actually 4 plus 1. That is the derivative. And wow. Well, the next one gonna be like a mixture of the rules. I mean, I think logarithm and power rule. That's just very similar to one problem we did before. So gonna be f of x. It is 6 is like a radical of x plus x to the square root of 6 plus square root of x, then square root of x. Then the rule is like a logarithm and the power rule. How many pages that I already used before? Then okay, just rewrite them just so it is easier. I write them in exponent form. It's easier for me to derivative. Okay, let me just now just apply the rules. Logarithm in f prime of x is gonna be a of gx. This is like the rule we used here. So let's back to it. So it's gonna be 6 to the x to the 1/2. The natural log of 6. Then g prime of x is gonna be, and there's gonna be square root of 6 x to the square root of 6 minus 1. And then use the logarithm differentiation. We need to simplify a bit. Plus this is, I can't just simplify them. And for one, you need to use like a logarithm here. I'll use like a logarithm. You just need like a natural log of y is equal to is gx. It is going to be x to the 1/2, and the natural log of x to the 1/2. This is the chain rule. Use like a product rule and then chain rule. So the 1/2 gonna be actually like a negative 1/2. Then minus like g prime x, and it's gonna be plus g prime x is when you 1/2 of x is like a negative 1/2. Like natural log of x to the 1/2. Oh wow, this is wild. Now you just gonna simplify the right side like a little bit because it's kind of like a bit like a messy. -1 plus 1/2 times negative 1/2. It's like natural log of x to the 1/2. And then like dy dx is going to be y times this whole thing. It'll be 1/2 to the negative 1/2 plus 1/2 to the x to the negative 1/2 times natural log of x to the 1/2. Then we got this expression is gonna be that f prime of x, it is x to the 1/2 x to the 1/2 times this whole expression 1/2 x to the negative 1/2 plus 1/2 over x to the negative 1/2 natural log of x to the 1/2. This is the answer that we expect. Guys, we're almost there. This is the final from, I think, the fall 2018, I guess. We have half an hour, so we can cover like enough stuff. So going to be final 2018. So question number 1. This is going to be multiple chain rule. I bet you may not like it. Was like natural log of 2 plus jeez. This is a mega combo chain rules. Multiple chain rules. So u equals 2 and the square root of x plus the natural log of 2 plus sine squared of x and the square root of x. It's derivative. It's the chain rule, chain rule, chain rule, chain rule. Oh god. Oh, geez. du is going to be 2 secant squared of x and tangent of x plus sine squared of x plus like a natural log of and then derivative gonna be sine over 2x over 2 plus sine squared of x. Why this is so complicated, dude?
Oh, bro, but I do. Because
and then you just
and I just rewrote the date on it.
found it's like f prime of x.
Yeah, I know.
It is gonna be the dx of tangent squared of x
I gotta go before.
plus natural log of 2 plus sine squared of x.
Maybe I'll see you in prom. Yeah.
and then du for natural log of u.
All right, I'll talk to you soon, buddy.
And then we have,
Bye-bye.
wow, this mess. Change the x plus sine of 2x, 2 plus sine squared of x. And then we have gonna be 1 over u. And then we can turns out like the prime of x, it is two secant squared of x and then tangent of x plus sine of 2x, 2 plus sine squared of x, and then we multiply by this over 1. So it's gonna be tangent of square root of x plus natural log of 2 plus sine squared of x. So this from we apply the chain rule by 4 times in a row. Four times in a row. I know this is complicated. Oh man. If you try to simplify this whole mess, we want to do it, then I can do it, okay. If you want to simplify it, just don't do it, because it's hard. Question B, it's gonna be like easier one. It's gonna be g of x. It is, oh, this is a product rule. So it has gonna be g of x. It is x, and then is cosine of this. Be 7x to the cubic plus 5 over x to the squared. This is the chain rule, man, and the product rule. You just rewrite this expression because just looks like a mess. Because this you can just avoid using quotient rule. It's a tricks here. cosine of 7x plus 5x to like a -2. And then use the power rule and the chain rule and then product rule. It's gonna be like it'll be like a negative x. So gonna be negative x 7 minus 10x is -1. 10 is -3 here actually. And then the sine of 7x plus 5x to the -2 plus just the cosine, because there is 1, right? It's cosine of 7x plus 5x to the -2. Geez, this one is significantly easier, right? Yep, it is. And I think this alpha like limit. That's alpha like a limit here. So I would just stop, like I need to stop like the recording because I know it's long enough. So thank you guys for watching, and it's in 2:42 right now. So I will going on like another videos going on like the limit definitions and implicit differentiation in the next videos, going to part 2. Thank you guys so much and hope you guys have a great day.